In this video, I'll explain you about my project. I hope you know what mnemonics are. In case you don't, mnemonics helps us to remember a set of words. The way it's done is we will have a beautiful sentence or a meaningful sentence that will generate that will encapsulate the first letters in the words that we want to remember. For example, if you're trying to remember the different layers in an OSI model, which happens to be physical layer, data link layer, and so on, 5 other layers, so we can generate a meaningful sentence of it. Paul did not take Sam's pineapple. So in this mnemonic that we have generated, we have encapsulating the first letters in the word that we want to remember. This is what a mnemonic is. There are so many websites that offer this mnemonic generation, but the problems with them is that they are using brute force technique to do it. And the second problem is that they can only encapsulate the first letter in the mnemonic. See, in physical word that you want to remember, only P is encapsulated in the word Paul, and D is only encapsulated, N is only encapsulated. And you see, what we want to do is we want more than one character to be encapsulated. That can be seen here, APP and APP. And the third problem is that imagine that we are generating more than one mnemonic. Okay, if you are doing so using the current techniques, there could be no meaningful linkage between the mnemonic 1 generated and the mnemonic 2 generated. What we want is that to ease out the remembering process, if there's some linkage, contextual linkage between the mnemonic 1 and the mnemonic 2, it will be easier for us to remember. For example, if the mnemonic 1 was Paul did not take Sam's pineapple, the mnemonic 2 could be because he doesn't like pineapples. So it's even more easier for us to remember the mnemonics. And we can go one step ahead and build a pictorial representation of these mnemonics. See, in this image, Paul is offering a pineapple, but Sam is saying no. Remembering this image will help us to remember the mnemonics better. I have divided this development process into 3 phases. The first phase in which I'll build a model that generates mnemonics. In the second phase, I'll build the model that generates contextually linked multiple mnemonics. In the third phase, I'm planning to build a model that outputs a pictorial representation of the mnemonics. I'm currently in the first phase. In the current architecture, the model will be receiving the words that we want to remember as the input, and the corresponding mnemonic will be the output. But what I'm actually feeding the model are only the first two letters of the words that the user wants to remember, because only the first two letters we are feeding into the model, because only those two first letters will carry the most information that we want to be represented in the mnemonic. I'm using 55k song lyrics dataset from Kaggle to do this. How am I preparing the data? I'll build a corpus of all the song's lyrics and keep it at one side, and each time I'll extract a sentence from it, and from each sentence I will extract first two letters from each of the words in that sentence. So in this case, hit me baby one more time, HIMEBAON will be my input, and the corresponding sentence will be my output. I want this to be fed into an embedding layer. So what I'll do is that I will convert this HIMEBA into one-hot encoding. So as there are there could be 27 into 27 different combinations that we can get. With addition, I'm also having a start word, end word, and empty word also. So I'm having a dictionary that maps different words like A to 0 1 AB202, something like that. I have my technique dictionary that maps these two pairs of letters to a number, and that will be fed to my model, and the output will be a glowy vector representation of the output word. If the word is hit, then I'm having a glowy vector that represents the word hit. In addition to the glowy vector that is going to be 300 dimensional, I'm also having a 32 dimensional vector for a corresponding word for HIT. The 32 dimensional vectors, there are 32 of I think there are 28 of these orthogonal vectors that I'm maintaining. And for each of this word, for example, there's an word called apple. So I'll take the first letter of the word, and I'll attach and for every letter there's a corresponding this corresponding vector for it, and all those vectors and all those vectors are orthogonal to each other. So for this apple, in addition to 300 dimensional glowy representation of apple, I will add in additional to it, I will add a 32 dimensional vector that is corresponding to the letter A. Yeah. And the different layers in my model are, first will be an embedding layer, and I'm projecting it to a 40 dimensional space, and after that I'm maintaining two bidirectional LSTMs, and my output layer will be a dense layer, 332 dimensional, and I'm using cost proximity as my loss function. Yeah. And deploying this model and training it probably for 12 hours, the results were kind of what I wanted and also kind of not what I didn't wanted. The results were able to match the first letters properly. For example, take this network session OSI model application presentation. For this, the corresponding mnemonic generated is this. See, the first two characters are properly matched. Not in this case, AP, but the problem with this is that the mnemonic so generated has no meaning in it, never seen, who, how, apart pretty 3 days before. The problem there was the input that I was using for my model while training were already in a meaningful sentence format. But when I'm feeding the test cases, network, session, OSML, they are not actually in a meaningful sentence format. So the corresponding mnemonic generator will also not be in a meaningful sentence form. So what I did was I took all the possible permutation of the input, possible permutations of the input, and I fed it into a bigram model that I had trained, and the one that had the highest probability of sentence formation, I fed it into my model and it generated the mnemonic. See, in this was the original one and this was the bigram version of it. So as you can see from it, the original version and the bigram mnemonic has little improvement over the one that didn't consider the probability of sentence occurrence. So instead of trying to go for a trigram model, I am thinking of using an LSTM to predict the sentence combination that has the highest probability of sentence formation and feed that to my mnemonic generator model. Thank you.